Hi there, welcome to this build of a 40-inch wingspan Keil Kraft Gypsy, a lovely Wakefield design by Bill Dean from 1949. Now, I started building this from a Ripmax kit, a modern laser cut kit, which if you've seen the previous episodes you'll know I've had some issues with, including the original plans which were the wrong size. But anyway, thankfully you can download the original Keil Kraft plans from the Outer Zone website for free, and there'll be a link in the description below this video. So, as you can see, we're at a really advanced stage with this, and I am really keen to get on and start covering the fuselage and getting this bird finished. But what I want to do first is I need to mock up the whole plane now with everything that's going to be fitted on it in the original model. So we need to put the wheels on. I've got those around somewhere. I want to get the rubber motor in, the nose block. I've got a couple of servos, one for the dethermalizer, another for rudder control, because this is 2-channel, dethermalizer and rudder. We need the rudder because where I fly, we can't fly free flight models. So, and I want to have the dethermalizer. One, because I just fancied putting a dethermalizer on it, but two, these models are really light and I've seen them fly and I've seen them go tremendous distances, and so just for safety. And if I've got the radio equipment fitted for the rudder, which I have to have, putting an extra servo in to operate a dethermalizer takes very little weight at all. So it's kind of, for me, it's a no-brainer. So I want to get everything in that, like the servos and the nose and the motor, that can't be moved, and the wheels, they've all got to go in a certain place. The only thing I've got left that I need to decide a position for actually is the battery. This is a 2-stroke 3 AAA battery. It's an overlander pack, and it's what, 4.8 volts. Now this is a square pack, but I'll probably end up buying another one and getting so they're all in line, so it's like a flat pack, just so I can put it in the fuselage. So anyway, I've got these two components, the radio and the battery, which I've got a little bit of leeway on, particularly the battery. Now I'm going to mock it up, see where the CG is falling, and then make provision to put the battery where it's needed. It might be that I end up sticking it in the nose and velcroing it down just under the rubber motor in the nose if we find this is a little tail heavy. It might be that we can, let me just take this off. I'm going to put a hatch on the underside here because we need access to the servo for the dethermalizer, and I put that servo right on the CG, more or less. Well, yeah, right on the CG. So it might be that I am going to make a little hatch there, which I need to do in this video, but it might be that I can just put the battery in and velcro it down on a little bit of a pad here, or even back here, but we will see. There's a little bit of balsa there I've got, which is a little bit of a pocket for a GPS tracker, which weighs about, I think it's about 2.5 grams. It's really, really light. So we're going to mock this up, pull it all together, and then that'll inform us as to where we put these two components to get that CG spot on. Because the last thing I want to do, or I'm not anyway, I'm not going to add any weight to this. You know, there's no point in having dead weight. We've got to make everything, like these two components, work for us to get that CG, to get it just right. And the CG is a good way back on this. It's about 50% of the, it's about 50% of the wing chord. So it's going to be an interesting exercise because I really don't know how this is going to work out. So I will start to get this pulled together. I'll get that hatch done and we'll see where the CG is naturally falling without these two components, and then we'll get them fitted. Well, I've got this all mocked up now, and it's good to see it in one piece and just to feel the weight and everything. But I've got everything on it now that has to be there but can't be moved. I've even got the tracer line here, the fishing tracer line, which I'm going to use to connect the rudder to the servo. I know it's all back here at the moment and it will be on that line, but there's very little weight to it, so it makes very little difference. I've obviously not got the covering on it yet, but I'm hoping that, I mean, the CG is about midway, so looking at the front and the back and thinking about the windshield to go on, there's probably not going to be a lot in it. It's probably going to add a little bit of weight to the tail, but we've got quite a large nose on this, so I think it'll even out pretty well. Now, the two items that we need to fit to this now are the receiver and the battery, and we've got a little bit of flexibility with these. Well, a lot of flexibility, and we may need just a servo lead to connect the electronics up. But it would be interesting now to see where the CG is falling, and if I put my fingers on the CG, which is just there, it is way tail heavy. Look at that. And I might even be slightly forward of the CG because it's quite difficult to hold that, but that is very tail heavy. Now, admittedly, I've added a little bit of weight in building the rudder and the horn here, and a little bit with the dethermalizer, but not a lot. And I've selected light wood where I've had to put it in here. The wood in this kit, because it's a Ripmax kit, and you know I've had my issues with this, some of the wood is like plywood, and some of the wood down in the tail was really hard, and perhaps I should have changed it. Certainly if I'd been building this from plans, I would have used a lot softer. So that's possibly why we've come out tail heavy, really. Now, we're not going to add any weight to this, we really aren't. We're going to get this to balance. So what I've decided is I can put a platform in the front here, in the nose, like this. And we've got this, it's a 2/3 nickel metal hydride 4.8 volts. It's quite a small battery. Now this is a square pack. I mentioned it earlier. I can get a flat pack which has got a very low profile, and I can put that in the nose there, and I can put it on some Velcro. So I can put in just a little piece of balsa that will perhaps span that kind of distance, put the Velcro on, and then we can move the battery just finely. If it's a low pack, it's not going to catch the rubber motor. That will all be fine. So the only thing we've got to do then is think about the receiver. But before we put the receiver in, let's just see how that is balancing, and that should have made all the difference. There we go. Now you can see that is possibly about on the CG, so that is a good solution. The battery we've got to have, so we need that weight in there. We need to put the battery in, so we might as well use that weight. With the receiver, I'm going to put it in the cockpit here, and we can get to that really easily from below the wings. So that will be really advantageous, and it's well up out the way of the rubber motor and the lubrication of the rubber motor, because we don't want that to get knocked or damaged with the rubber motor and perhaps get some oil and affect the electronics. So I think that is a pretty good solution, providing we can manage the battery there. How's that looking? That is looking pretty sweet to my mind. It might be, as I said, we get a little bit more tail heavy when we get the covering on, and if we do, we can just slide the battery forward. What I might do is just take a piece of balsa like this, fairly narrow but long, oops, and it might be worth actually just putting that piece in sort of over that period, that distance, Don't know, can I get it in here? No, yeah, just something like that, and glue that down to those spars. So we've got quite a distance over which we can velcro this battery to fine tune it. And like I say, if it's one of those flat pack batteries, it'll be half the thickness of that, so we're going to be well clear of the rubber motor. But I'm really pleased with this, and it's, like I say, it's been a good exercise to know where we are, really. Actually, the wings want to go slightly further forward, just a tad. There we go. I don't think that'll make any difference, but I find doing this kind of mock-up with a CG essential if we're going to get this balanced without the extra weight. And as modelers, the last thing we want to do is build something that we're pleased with and we like, and then, you know, and it's worked out quite light, and then we have to put a shed load of lead in the front or the back just to get it to balance. You know, we want to work this and manage it as we go along, like we're doing today. So what I'm going to do now is I'm going to get all this taken apart, I think, and it'll be good to get this sanded up, ready for covering. Right, well, I've now been working on this since we had a look at the CG, and we know roughly where we stand. And you can see I've put in this piece of balsa here, just stuck it down to those cross pieces, and I'm going to put some Velcro on there so that the battery can just slide in the nose, a flat pack like I said, and I can use a pair of long forceps just to decide where exactly that goes to get the right CG. Now, I obviously need a lead to bring round up to the receiver here, and so I've put in a couple of, you can just see there's a piece there for it to thread through, just to keep this out the way. And I've also put a cross piece, I don't know whether that shows, just there for the wire to go under, and and another one just there, hopefully you can see that, just to keep that cable out the way. Last thing we want is that getting tangled up with the rubber motor. From here up to there, I've put in a piece of balsa there, look, I don't know whether that, yeah, I think you can see that, and that we can thread the servo lead and this extension up between the tissue and that will bring that up there, and then we can thread it underneath and to where the servo is. Sorry, not the servo, the receiver. And that, if I just do that now, that will keep that wire out the way, and the same with the wire from the servo. And now if we look, I don't know whether I can, if we look down there, if I can line that up, you can see it's well clear of where the rubber motor is going to go. So just thinking ahead really how that's going to work. Now I've put in a platform here and a little bit of strengthening, just some 1/8 on either side, because if I'm pushing the receiver in to stick it on the Velcro, and I'm putting in the sockets or the plugs, sorry, into the receiver, it would be nice just to be able to feel slightly more comfortable pressing down on that. So that's going to go there. We've got the leads coming up to it, and again, well out the way of the rubber motor. Now the only other thing to show you that I've done, actually no, there's two things. I've put in a little bit of strengthening just here. I just didn't like that, the fact it just seemed a weak point with the wing attachment there. I've done the hatch for the underside, so we've got the servo there, we've got a hatch, and if I just get an elastic band, and I'll show you how that's going to lock in, I'll just move the camera, there we go. So we've got a hatch that I've made, and what I'm going to do is just put an elastic band around that tab, and then we can just slot that in like that. I might just make that slightly smaller so it slots in a little bit easier. So that slots in, we've got the elastic band, and then I will probably just put in a couple of bits of wire hooks here and CA them in, and that can just come like that, and that will hold that in place. It won't come out, and I mean, there's not going to be a lot of force on that, and that's a really light solution. I didn't want to put catches and things like that, so and the trick is to keep the weight down as much as possible. It's going to be heavier than it should be because of the radio equipment, so where we can have an effect, let's keep that as light as possible. And in that vein, I had some little bits of balsa here which I've taken out when I originally had the peg for the dethermalizer down here. It wasn't as good. I've also thinned out this balsa here as well, just trimmed out a little bit. Won't make a lot of difference, I know, but every little bit counts. Well, I think this has been a really valuable exercise. I feel really assured really and confident that we can get this finished, we can get it balanced, and we're not going to be having a problem with the CG. We can get it to balance. So I feel really pleased about that. I think this is such an important exercise. One thing I will do, and once I've sanded all this and we're ready to cover it, I will put the Velcro on this balsa plate here ready for the battery, just because without the covering it's a lot easier to get in and just push it down and make sure it's nice and secure. So anyway, I'm going to draw this video to a close now, and in the next video we're going to be looking at getting this fuselage covered, or at least starting the covering process, and that's going to be laminating film, and it's going to have a tissue on top. Laminating film will just make it more resilient, less likely to puncture, but the tissue will give it a lovely traditional look. But anyway, I hope you've enjoyed watching this. Thanks very much, and please come back and see how we get on covering the fuselage.